Okay, class, welcome to Math 2020 video on handout 4.3. We're going to apply our triangle congruences to little figures where we can find some lines, some segments, and some angles that are the same. So in this section, we're applying them to show equality between corresponding sides, corresponding angles. The main approach to these types of problems is one, you want to identify what you're proving in the figure. It will be the correspondence that you want to show. And that correspondence you cannot use in your triangle congruence test. Two, you want to identify two congruent triangles that share the correspondence. This is important. To know how to prove that two segments or two angles are equal, you need to pick out two congruent triangles that they're a part of. The full segment is a part of is the easiest. Third, you want to identify the clues that are given so that you can select the triangle congruence test to use. Remember that we had 6 triangle congruence tests. And once the triangles are shown to be congruent, you'll use a new property called corresponding sides or angles of congruent triangles to show the correspondence that you want to prove. Okay, so congruence tests review which ones do work. So we're going to go through all sets of 3 things. So on the side here. So the first one is angle, angle, angle. Okay, do not try to show that 3 angles correspond to use a congruence test. That one does not work. Okay. The next one is, that's all 3 angles. Next one is 2 angles and a side. So angle, angle, side is good. Shown that last time. The other one is 2 angles that have the included side in them, called angle, side, angle. That one is good. You can use that one. Next is 2 sides and an angle. So side, side, angle. Do not use that one. Bad word if you rearrange the letters. So if you're trying to show correspondences between one side and any other side and any other angle, not included in between the 2 sides, then you got to have red flags come up because you can't do that. So the one exception is called RHL. If the angle is right, and one side is the hypotenuse of the right triangle, and the other is the leg, then you can do it. So it's pretty strict conditions, but you can use it, and it happens. We set it up in the homework that happened a few times. Okay, and then you can use side, angle, side, which is the other congruence test with 2 sides and 1 angle. That's how it works. And then the last congruence test is all 3 sides. If you can establish the fact that all 3 sides are equal, then all the angles will be forced to be the same. Okay, so those are your 3 congruence tests. Remember that we're going to look at clues in our figure with marks or what's given in our sentence to see if we have the correspondences we need to use the congruence test. Here's example number 1. In the figure, prove that BD is equal to DC. So I'm going to zoom in here. This is what we need to prove. So I'm going to highlight that in green. BD is equal to DC. Okay, these 2 segments here we need to prove are equal. Now the first step is you identify in your figure what 2 parts need to be shown to be the same, shown to be equal. And therefore I can't use those 2 sides in my congruence test. I need to look at other clues to prove that 2 triangles are congruent. First, we're going to show with red and blue which 2 triangles I'm going to prove are congruent. This one is a little bit like one from the handout from 4.2, and I'm going to show that that blue triangle is congruent to this red triangle. Okay, what kind of clues do we have already? we have that D, angle ABD, so it's not just D, angle ABD is right. Okay. All right. And I'm going to go ahead and just name this angle ABD. I'm going to use a little letter. So we'll call this angle A and this angle B. So angle B is equal to 90 degrees. We need to show that A is if we want to use this as a correspondence, we need to show that A is equal to 90 degrees. Okay, because it wasn't given to us, even though we kind of glossed over that in our handout. Notice that we have two tick marks here on AC, and so that means it's equal to AB. Okay. Sometimes it will tell us in the directions, and sometimes they won't. Okay, so here's one correspondence, here's another correspondence. Okay. That is an angle and a side. Angle and the side. So let's see. Since my angle here is a right angle, I'm going to go for RHL. Okay. So there's my right angle correspondence. So we try RHL. Every time I see a right angle, that's my go-to, because it's likely that that will work out. Once I show that, using RHL maybe, that the blue triangle is equal to the red one, congruent to the red one, then I can use my corresponding sides of congruent triangles, or corresponding sides, to show that BD is equal to DC. So that's my overall goal again. Now let's take a look at what I was given from AC and AB. Those two sides are the same, but they're opposite the right angles, so that means that these are the hypotenuses. Now, can I prove that one leg is congruent to another leg? That's all I need. Now, the leg BD and DC, these ones right here are legs that I need to prove are equal, so I cannot use those in my congruence test. The only other leg is AD on the blue, AD on the red. Now, these two legs are lying on top of each other, so that means that they have to be equal by common side, as we proved from the figure. Okay, and therefore RHL will work. Okay. So to start the teacher solution, I need to begin this procedure by saying which congruence test I'm going to use. Okay, and so we're going to use RHL. So let's zoom in a little bit more here. Right hypotenuse leg. Now I'm going to establish my right angle correspondence. Notice that A is not given to me to be right, so I have to prove it. So right is, I know that B is equal to 90 degrees. Okay, that's given. I only say that because I'm going to use it in angles on a line. So actually, I don't need to say it because I can just use it. So let's go ahead and just use it by using angles on a line. So we have A plus B equals 90 degrees, or 180 degrees. Okay, from angles on a line. Okay, oops, sorry about that. So A plus 90 degrees equals 180 degrees. So you can start with this line here if you want. Subtracting 90 for both sides, you can get that A is equal to 90 as well. Okay, that equals B. And so now that I've proved that A equals B equals 90, I can go ahead and put that into my figure. And I can say, okay, my right angle correspondence is made. The next we're going to do the hypotenuse correspondence. Okay. And if you need to do some extra work in each of the categories, do it in the sections. So notice that I needed to show that A was 90 degrees for my right angle correspondence. I keep all of my work in that section to keep it coherent and neat. Now the hypotenuse correspondence was given to me because AB was equal to AC. So we say given. Next we have our leg correspondence. The leg correspondence was AD equals AD. Okay, so the same segment from the blue triangle and the red triangle are equal to each other. Okay. And because of that, we can say that that's common side. Now, just like in the handout from 4.2, we've established these three correspondences. Now we need to say that the triangles are congruent. That's sufficient for forcing all of the other three correspondences to be the same. So triangle ABD is congruent to triangle ACD. Okay. And the reason why we can say that is from RHL. Now, we haven't proven what we came out to prove. We wanted to prove that BD was equal to DC, those green parts. And so, once we've proven the triangles are congruent, like we've said before, all the other parts are congruent. That means that BD is equal to DC. That means that angle ABD is equal to angle ACD. So what we have here is the last statement is going to be what we're proving. Therefore, BD is equal to DC by corresponding sides of congruent triangles. Okay. So these sides are congruent, and this is a special property that says, okay, I'm going to focus on, okay, reader, focus on just those two segments. Because there are more parts that are congruent, but I'm only worried about those two segments. So, and we have finished our first example. Here we are in example number 2. Let's take a look at our figure and what we've been given. Sometimes we need to make some marks on our figure based off of what was given. In the figure, BP is equal to QC. Okay, so they've marked that with 2 marks here already. These are the segments that we're talking about. AP is equal to AQ. So AP is this one, AQ is this one. So those are already marked as equal. X equals Y. Okay, so they mark these ones with 1 mark. Prove that AB is equal to AC. Okay, so I'm going to highlight in green here what we need to prove. And that's this one right here. This segment I need to prove to be the same as this segment here. AB equals AC. Okay, so the next step after identifying which parts need to be shown to be the equal, then I need to identify 2 congruent triangles that share those parts so they can show the correspondence. Okay, so I'll do that with my red triangle, my blue triangle. And it looks like these parts, there's a number of triangles in this figure, but it looks like these 2 parts are centered around, there's 2 sides that are centered around these 2 triangles here, and the one that I'm looking for. So I know that that with that red triangle there, that blue triangle there, and this red one here, I can get at what I need. So if I show that these two are the same, then I can say that the B is equal to AC from corresponding sides of congruent triangles. Okay. Now let's look at a congruence test. I have two sides that are the same, so it's not going to be like the angle side angle type of a thing. Which ones have sides? Well, we have side, 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 and we have side angle side, or RHL. Now those two RHL can't use. Let's look at side, 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 or side angle side. First, side, side, side means that I need to prove that this side is equal to this one. Somehow I need to be given that. But that's actually the sides that I want to prove are the same, so I can't use side, side, side. The only other option is side angle side. And this you can kind of deduce yourself or learn how to do it by looking at what the list of possible congruence tests. Now in side angle side, if I choose these triangles here, I don't have this angle here. That's the angle I need for side angle side, because you have side angle side, side angle side, okay? So I need to think about how to get that angle. So I would go back to my clues and look at what's given. I'm given that x is equal to y. And they happen to be angles on a line with the ones that I want. Okay, this will come up a couple of times in the homework. I need the angle that shares, that's supplementary to given angles. Okay? So two given angles like x and y are equal, but I need their supplements, or the angles supplementary to them, because of angles on a line, to be equal. And so we'll use angles on a line to do that. So my thoughts here, as I write them down, are to use side angle side. And I have the two sides that are the same, but the angles are the tricky part. Okay. Since x equals y, I can show that the two supplements are equal. Let's name them A and B. I need to show that A equals B. Once I show that A equals B, then I can say that I have my angle correspondence for side angle side. The other two sides for side angle side were given to me. Okay. So we'll erase that. Now let's go ahead and explore a couple ways to show that A equals B. We know that x, and see which one you like here. Let's see. Oops. We know that x plus A is equal to 180 degrees. That means that x is going to equal, we also know that y plus b equals 180 degrees. And so if we set those equal to each other, we can say x plus a equals y plus b. Okay. We set them equal to each other because they're both equal to 180 degrees. So if they're both equal to the same thing, they must be equal to each other. That's an algebra move. So we want to say, okay, since x is equal to y, I can interchange any y for x. So x plus a is also equal to x plus b. Because of this is substitution, so I don't need to say anything in particular with that one. It's not a geometric move. Because those are equal, I can subtract off the x's, and I can say that a is equal to b. Okay? So that's my steps to show a equals b. Now that's the major part of that's the most complicated part of my proof, or my congruence test. Okay, all the other ones are trivial because you just say that they're given to you for the sides part. All right, now that we've done that investigation, let's look at the teacher solution. The teacher solution will begin with using, and tell my reader to use side angle side. The side correspondence is going to be given from my figure. Let's start with the first tick mark, 1 mark. So AP equals AQ. And again, when I'm doing this congruence test, I'm showing that the red and blue triangles are congruent, and then I can say that the green segments are equal. Okay, that's what I'm proving. So those are my overall. So you can go to different levels of your proof. You can look at the minutia for each side angle side or anything like that, or you can do an overall look at it and to see, make sure you're headed the right direction. Okay, so angle correspondence was the longest one here. Oh, and the side correspondence was a given. Okay, always put your reason why. Okay. So using angles on a line, I'm going to say that x plus a equals 180. If you're going to use any letters that you make up in your teacher solution, show on the figure where they are at, so I can follow that. Okay. Now x plus a is equal to 180 from angles on a line. Okay. Well, we can also say that y plus b is equal to 180. From angles on a line. And because that's true, we can say that x plus a equals y plus b. Okay, that's an algebra proof, doesn't need any reason. We're given that x equals y, and that's key here, because I'm going to substitute in the x for the y. Next. Okay, that's substitution, so it doesn't need a reason. And I can go ahead and subtract off my x's and get a equals b. Okay, so my angle correspondence is made. Okay, it took several steps, and this is something that you will do in another couple of examples from the homework. Now that I have my side correspondence and my angle correspondence, let's do my other side correspondence. With the sides with 2 tick marks. BP is equal to QC. Okay, that was given. Once I make my 3 correspondences, that forces all the other 3 correspondences from the blue triangle and the red triangle to be equal to each other. If I make my congruent statement, so I say triangle ABP is congruent to triangle ACQ by my side angle side correspondence test. And because those two triangles are congruent, all the other parts are the same. So AB, so therefore, AB is equal to AC. Okay, now the reason why that's true, why those two sides are the same, is because they correspond in these two triangles. So we say corresponding sides of congruent triangles. Okay. And so there's our second one. Here is example number 3. Let's go ahead and start by investigating what our directions are, and identifying what we need to prove, and then identifying the 2 congruent triangles that we need to show are the same, so are congruent. And we're going to look at this one bigger. In the figure, A1 is equal to B1, so those are angles. And those are marked. So here's A1 and B1. A2 is also equal to B2. So we mark those with 2 marks. There's A2 and B2, the little skinny ones. We need to prove that AC is equal to BE. Okay, proving that AC, that's this whole long thing here, that side is the same as BE, which is this long side here. All right, now those 2 sides are part of 2 congruent triangles. We're going to identify them with our red and blue, and there's a couple ways of doing this one, but the easiest way is to just keep the sides intact for AC and BE. Now, these 2 triangles are lying on top of each other, so it's kind of hard to see it sometimes, so you have to kind of parse it out in your mind. Okay, so that's why I use colors to help me. So the blue triangle is the first one I'm going to highlight here. And, okay. There's that blue triangle here. This triangle contains EB, the entire side. So you can separate the segments out if you want, but it's easiest to keep them together and identify just these two triangles here. That was the first blue triangle, and this is the red one. Nice the big triangle here on the outside here. This triangle is the other one that I'm going to show is the same. Okay. So we're showing that the red triangle, the blue triangle are congruent. Now what clues did we have again? Well, we had that this segment right here, or this angle right here, was equal to this angle. So A1 equals B1. And then A2 is this angle right here, equals B2, which is this angle here. That's all I have. So two angles are already given to us to be the same. And so I go back to my triangle congruence tests, my list, and I look at the ones that have two angles. We can have angle, angle, side, and angle, side, angle. So there's only two congruence tests possible to use from what's given. Let's take a look at angle, angle, side. That one is where I have these two angles, but any other side except for the included side. So which means that I can use these sides here on the outside, the long ones, or I can use these sides here on the outside, these on the left and right sides. If any of those two are given, then I can use angle, angle, side. But I cannot use the ones on the left and right side because they're not given to me as equal. And the ones that are with one tick mark I've marked are already claimed for what we need to prove, so I cannot use those ones. The only other side that I can show is this side from these triangles down here. Okay? Because angle, angle, angle is not a valid congruence test. The sides that are marked with 3 marks are from the red and blue triangle, as you can see, lie on top of each other. Erase these ones. Okay. They lie on top of each other, and that means that they can coincide by doing common side. Okay, so I'm going to use that to my advantage here. Okay. Note too that the angle for the blue triangle on the left here, this is the one that I need right here, blue triangle only. And I need this one from the red triangle. Those can be obtained by adding the A1 and B1, A1 and A2, and then B1 and B2 with the angles add. Okay. So what we've done in summary, which we're going to write in our scratch work, we're going to want to use our angle, side, angle congruence test. Now the first angle we'll do is A1 plus A2. Set that equal to B1 plus B2. Okay, that's what we want to say first. Now we can obtain these by saying, okay, I know that A1 equals B1 from my given, and B2 equals B1 equals B2 from my given. If I add these two right here, oops, hold on, let me get that straight again. Let me go back. Just start that over. Okay. From my givens, I know that A1 equals B1. That's this one here. And I know that A2 is equal to B2. Okay. Now I can find the big angles here by adding these two up and getting this side right here. I'm going to add these two up and get these side right here. So I can add left and right sides of separate equations and set them equal to each other because they are all equal. This is an algebra move. So I can add those together. That's the angle part. Okay, so that's my angle part. The side part is the common side, which is AB is equal to AB. Okay, so that one is good. And then the other angle are the little angles. A2 and B2, because they're right at the points here. There's A2 and B2. That's the little parts of the blue and red triangle. Okay. There's the other angle. So once I can use those to prove my red and blue triangles are congruent. There are some people who, with the line on top of every of these parts, distracts them a bit. And so I'm going to go ahead and separate this out for my scratch work, and I'm going to show how you can take a look at these two triangles by separating them out. Okay. The two triangles can be separated out into a red triangle and a blue triangle. My blue triangle I'm going to draw this way. Okay, it's even more angled than that. That's better. Okay, so here's my blue triangle. I'm separating it out from the figure. Here's my red triangle. So I'm going to go ahead and label my points so I can keep those straight. This is point E, this is A, this is B, and this is also A here, and this is also B here, and this is point C. Okay. So I have my red triangle, my blue triangle. They told me that, let's go ahead and do some labeling here. Okay, I wanted to look at my side angle side here. I want to show that that angle is equal to this one, that this angle is equal to this one, and that this side is equal to this side. Okay. This angle right here is going to be A1 plus A2. Okay. If you notice that on the figure, you combine both together. This angle here is B1 plus B2. This angle here is A2. And this angle here is B2. Okay, so we have those labeled. These two sides are AB, and they correspond on top of each other. They coincide, so they're common sides. Okay. So here you can identify the side angle side from both triangles separately, if you prefer that way. Let's go to our teacher solution. We want to use side angle, so let's start with that. The angle correspondence is what we'll start with. Okay, the first one, let's do the longer one. Okay, now I'm starting with A1 plus B1, or A1 equals B1. That was given to me. A2 equals B2 is also given. Okay, then I go ahead and add those together. A1 plus A2 equals B1 plus B2. That's an algebra move. Okay, and so we don't need any reasons for it, for geometric reasons. And since that's what my angle correspondence is, I can go ahead and move on from here. So the obtuse angles were bigger, A1 plus A2 and B1 plus B2. Now I'm going to show my side correspondence. Oh, gosh. Sorry about all that jumping around. Watch where my hand goes. Okay. side correspondence now. That side correspondence was AB equals AB. Okay, AB from the blue triangle equals AB from the red triangle. And we call that the common side. Okay. So that is equal to that. So we are done with the side correspondence. And then the last angle correspondence is A2 is equal to B2, which was given. Okay, I've established my three correspondences, and now I can say that the two triangles are equal. So triangle EAB is congruent to triangle CBA from ASA. Now my goal was to prove that these green segments are equal, which is AC and BE. Because the red triangle and the blue triangle are congruent, and using angle side angle, I've only established three correspondences, but it forced all the other three correspondences, including my green sides, to be equal. So therefore, we can say that AC is equal to BE, which is what we wanted. And that is because of the corresponding sides of congruent triangles. Okay. So that's number 3. For example 4, we are going to take a look again at what we need to prove and then what we have. Okay, so zooming in on this one, I'm going to, in the figure we have some things that are equal. Let's go ahead and mark them since nothing's equal, marked in the figure. We have AB is equal to CD, so mark that as with one mark. Those are the top and bottom. BC equals AD, so that's these two on the sides. So that's good. Prove that angle ADB is equal to angle DBC. Angle ADB, that's this one here, is equal to angle DBC, that's this one here. Okay. So those two angles need to be shown that they are equal to each other. Let's go ahead and do number A, letter A first, and then we'll worry about B. So we're focusing on those green angles. We need to show that they are equal to each other. And in order to do that, we go to the next step of our general method and outline two triangles that those are part of. Those two angles are part of two congruent triangles. There's a couple of options here. I can take this triangle here and this triangle here if I want. Or I can take this triangle here and this triangle here if I want. Okay, because those two green angles are part of those two congruent triangles. Two sets, two possibilities. If I keep these possibilities out, I have more of my givens connected to the triangles. So it looks like let's go for those. Okay, so we're going to go for those two triangles, and I'm going to outline it with red and blue. It may work, it may not work. So if it doesn't work, then I will make an adjustment. Okay, so there's my blue triangle. There's my red one. Okay. All right, so these are the angles that I'm still looking for here. Okay, now with this side here, purple, let's go back to our givens. I have these sides are corresponding and they're equal. These two sides are also corresponding equal. So I'm given that two sides are equal. So either I have a side angle side approach, or side 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 approach, or the right hypotenuse leg. But there's no right angles, so I can't use that one. So it's either side 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 or side angle side. Now the included angle between those two sides, if I'm going to try side, 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 is right here, this one and this one. I don't have those as equal. If they were if this was given to me as a parallelogram, for example, then I could show that opposite angles are equal. But there's no indication that this is a parallelogram. I don't know that DC and AB are parallel or AD and BC are parallel. Okay, so I can't use that fact. Don't assume that these two are parallelograms or a rhombus or something like that. Okay. So the other option is side, 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 and the other side of these two congruent triangles is right here. Now this looks like it's promising because on the red and blue triangles, DB is common between them. Okay? So it looks like we'll be using side, side, side. Okay. So our goal is to show that the red and blue triangle are congruent with side, 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 and then show that the angles ADB and DBC are equal through corresponding angles of congruent triangles. I'm going to go ahead and show you that with the teacher solution. You can do as much of the preliminary work and scratch work as you would like as well. So first we're going to show that we're going to use side, side, side. Okay, my first side correspondence, let's start with the one tick marks, is AB equals CD. Now that one was given to us. Next, we'll do another side correspondence. We'll do the two tick marks, which is BC equals AD. And that was also given to us. The third side correspondence we deduced using common side, so DB equals DB. And that's from common side. Okay. Now because we use side, 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 we've established these three correspondences. The triangles that we wanted to be are congruent. So blue and red triangle. So we're going to say, sorry about all that. So we're going to say that triangle ADB is congruent to triangle DBC. Okay. Which those are congruent by side, side, side. Okay, now I'm going to say that the angles are congruent. Angle ADB is equal to angle DBC. Okay, that's from the idea that corresponding angles of congruent triangles. Okay. So we have our thing that we want to prove, that's the therefore. So put that there. So that was all from part A. Part B. In parts A and B, we have, usually A helps us, okay, with B. We need to show that AC and BD bisect each other. Let's go back to our figure. AD and BC bisect each other. So here's our AC and BD. That's these ones here, the diagonals. I need to show that they bisect each other, which means that this segment, I'll use 4 marks because I already have 3 marks, is equal to this segment. Okay. And at the same time, 1, 2, 3, 4, 5, that segment is equal to this one. Okay. The diagonals bisect each other. That means those little small parts are equal. Okay, I've identified what I need to show are equal, and I have two sets of things that I need to show are equal. But it's okay because in this figure, and it happens to be, I can just show with those two sets are equal through one triangle correspondence. So we need one additional triangle correspondence to make. Okay. So I'm going to pick two different colors to find, because once you know what parts you're looking for, you look to see which two triangles they are part of. And so I'm going to use an orange triangle, and I need to show that all of those are equal. So I could do something like this, where this triangle in here is congruent to this one. Okay, because this side right here is the same as this side down here, they correspond. And this side right here is the same as this side right here, they correspond. I could use those two triangles. But do I have the clues I need for it to show that they're the same? So let's take a look at the investigation of these clues. I have that this side is equal to that side. I have that, I'm guessing that's about all. These angles are the same here. This angle equals that angle from vertical angles. Okay, so I have a side and an angle. So with side and angle, I can do angle, side, angle, or side, angle, side, or angle, angle, side. So if you get stuck, maybe you can try another angles. There is a possibility of making that these angles are the same here. Okay. But what I like better than that, you can use that approach if you want. But what I like better than that approach is this one. Using the angles that I have already shown to be equal, I'm going to make this orange triangle congruent to this orange triangle. That way I can use the green angles that I already shown were the same. So we'll go back to green. These angles are already given as equal. Okay. I can use my vertical angles. Vertical angles here are equal, and then this side here. Okay, so I have angle and an angle and a side. Okay. So for part B, we're going to use angle, angle, side, which is one of our congruence tests. Now the first angle here is going to be from part A. Okay. We've proved that those two angles are green, are equal. This angle is going to be from vertical angles. Okay. And these sides are going to be given. The ones marked with 2 tick marks. So it's a little bit easier to see those ones, these two, but you can also do it with what I had before, the top 2 triangles also. Now, in part B, I'm using use this blue here. In part B, I'm using what I've done from part A. So let's go ahead and see how this will work out for a teacher solution. We're using angle, angle, side. Okay. Now my first angle was from part A, so angle correspondence. Remember, my goal is to get those yellow segments equal to each other. If I prove that the orange triangles are congruent, then I can use the corresponding sides to show that those are equal. Okay, so that's my overall goal again. So let's go back to what my little goals are: angle, angle, side correspondence. Now we know that angle ADB is equal to angle DBC. That's from part A. And so I can go ahead and say that. Okay. We've already proved it before, and what's great about deductive logic is I can use what I proved in part A and part B. Okay, and that's when there's a couple problems on the homework where you have A and B's, so use those things, those clues. All right, now the angle correspondence there is complete. Now let's say the next angle correspondence is going to be angle DPA. Okay, so I'm looking at this angle here, DPA and CPB. Okay, you can use letters, little letters there if you want, but those are vertical angles. Next is, oops. I want to kind of erase these little marks here. Okay. The side correspondence. This side correspondence is BC equals AD, that one that they gave us. Now I can say that these, since I have made these three correspondences, I have two congruent triangles, those are the orange ones, so APD is congruent to CPB by angle side. Okay. Now from here I need to say that the segments are the same. Recall that I'm going to use these yellow parts here. I need to say that this yellow segment is equal to this one, and then this yellow segment is equal to this one. And since I'm using my thing I'm proving is A, C, and B, D bisect each other, I don't need to use therefore until the end. So we can say that AP is equal to CP. Okay. We know that that's true from corresponding sides of congruent triangles. Okay. The next one is the DP and BP one. DP is equal to BP, the shorter of the two sides that make up the diagonal. Okay. Corresponding sides of congruent triangles. So now we've shown that those two segments separately are equal. Because they're all equal, AP and CP are equal to each other, DP and BP are equal to each other. So AC and CP are equal to each other, DP and BP are equal to each other. That means that they bisect each other. So we can now say our last thing that we're trying to prove, which was AC and BD bisect each other. Okay, that's what we wanted to prove. And the reason is from definition of segment bisector. Okay, we can use that definition because that's what it means. A segment is bisected when it's split into two equal parts. Okay. So there's a good one there. Some final thoughts. To show that two segments are perpendicular, okay, you want to show that two segments are perpendicular. Okay, just that, which means that they meet at 90 degrees on one side and 90 degrees on the other. You show that they are equal to each other. Okay, so just like the green parts that we use, we show that these are equal to each other first. We say that A is equal to B. Okay, and then you can say that they are both 90 degrees if you use angles on a line. A plus B equals 180 degrees. Angles on a line. And if you do that, then you can say that, oh, and A equals B, so I can say that A plus A equals 180. And that means that 2A is equal 180, and that A equals 90, okay? So you show that they're the same first, using congruent triangles. And then, since they're the same, you can solve substitute in like the A for the B, and then solve it for A. And then that means that that is also equal to 90 degrees. So B is also equal to 90 degrees because of substitution. Okay. Now that both of them are 90, we can say that they're perpendicular because of definition of perpendicular segments. Okay. Kind of like what we did here, definition of segment bisector. The next tip or thought is to show that a ray bisects an angle. Okay. So here is my angle. And I'm going to draw a ray in the middle of it. Okay. And that is going to be showed, I need to show that that's bisected. So in order to show that, you need to prove that the two angles made by the ray are equal. This is one angle here. This is the other angle here. Okay. Those two yellow angles need to be shown that they are equal. And when you do that, then you can say that the ray bisects this angle by definition of angle bisector. I'm going to show yellow angles are equal. Okay. Okay, first thought here, second thought here, and third thought here. To prove that three segments are equal, you need to show that one segment is equal to another by using congruent triangles. Okay, so let's say that AB, we want to say that AB is equal to BC, which is equal to CD. Okay, three segments are equal. First, you want to show that two of the segments are equal. So take the first two or the second two or whatever. Okay, show that you want to show, can't see that very well, that AB is equal to BC first. Okay, you will probably have to do this with a triangle congruence test. Okay, then you want to show that, let's say BC is equal to CD, show that the other two segments are equal. Okay, so that's these ones here. You will probably also have to do a triangle congruence test. And once you've done that, shown that AB equals BC and BC equals CD, then we've shown that AB is equal to BC, which is equal to CD. Okay, we get what we want. Okay, so those are some tips. This is a pretty tricky section, so feel free to send me an email or request a Zoom meeting if you have any questions. And hopefully you guys will have some prep, and you might need to view this video a couple of times. You can also read through the section in the book. Please do that to get an idea of what their opinion is. Okay, but mostly the videos are what's going to be helpful for you. All right, good luck.